let's just dive right in here. On my screen, I have while we wait, if there were no draws or blockers in poker, would you still merge bet? And it's a fascinating question because, I mean, okay, presumably you know that if I'm asking this, I'm asking it because I'm trying to trick you, right? But there's a reason why I'm asking this question. And I think we have this idea of in poker that we're often betting medium strength hands for some reason or another. But it only exists because of this very peculiar nature of poker that we don't know how good a hand is until the river. So I'm going to get more on this later, but I think you might be surprised to learn just how profound the impact of draws is on poker. Without further ado, let's talk about the science of draws. So, do you guys ever struggle to play your draws? Does it feel like the solver does anything and everything with a draw all the time? I know that when I first started studying GTO poker, I was kind of surprised that there was no seemingly correct way to play a flush draw, for example. It seemed like you can just kind of do anything with a flush draw. And there's a reason for that, actually. And it has to do with this concept of scarcity. If you have a draw and you always take the same lines with the draw, well, then your opponent can just not pay you off when you hit and, dominate you when you miss. And conversely, if you don't take that line, then they're going to know you don't have any draws in that line. So draws are kind of the wild cards of poker because you have to spread them out throughout all your different betting lines in such a way that they are representative in all different lines, right? You'll even have flushes in like check down lines, for example. Okay, what to expect this session. This is going to be more of a conceptual session. I'm going to start by trying to give you guys some practical advice and tying together some like really abstract concepts. Then we're going to walk through some toy game math and we're going to end with some GTO Wizard exploration and some practical takeaways. So it's going to be a good mix of like practical advice and abstract theory, my usual take on a coaching session if you've seen my stuff before. The first concept I want you guys to wrap your head around is that everything draws. Every single hand is drawing, at least in my framework. Draw completers tend to devalue previously made hands, but I want you to think about it this way. Even if your hand doesn't really feel like a draw, it is still affected by draws. So even if you have, let's say, a made hand, you could draw to a better made hand. Two pair can draw to a boat, right? Every hand is drawing. And similarly, if a different draw gets there, let's say you have a set and now the flush completes on the turn, well, that devalues your set. And so it is still affected by draws. And to me, what is the nature of a draw? It is just the reshuffling of the hand strength order. So that's all draws do is they just change the order of hand strengths. And so no hand, be it a made hand or draw or complete dare, is safe from this effect except for the stone cold coconuts. So when I say this, let's just take a quick look at GTO Wizard here. So this is cutoff open, big blind call. I'm using a cash game example, but this theory applies to all formats. We have Jack 9-5 on this board. Cutoff C bets, 1/3 pot, and the action is on us in the big blind. Now, in this spot, what most people would do is they would say, okay, open ended straight draws, these are draws. Gut shots, these are also draws, right? But the way I want you to think about it is that every hand is a draw, right? King Jack is a draw, right? Ace Jack is a draw, Jack 6 is a draw. Every single hand is drawing. And so the way you have to think about poker is, in fact, maybe I'm just going to put on a flush draw version of this. Okay, let's take a look here. If we have a hand like deuces here, we're kind of indifferent between calling and folding. A hand's not very good. It doesn't really, like, this feels as close to a static bluff catcher as we can have, right? But let's say we call with deuces. What we're going to do now is take a turn and we're just going to wait for these reports to load. What I'm going to do here is filter for deuces. So we have 2-2. We've called in the big blind. And I want you to note that if we have 2-2, what we actually have is a draw, right? We're actually drawing to two outs. That's what we have. And we'll notice that one of these outs is poisoned. This is a two of clubs. Notice that it has half the value of a non-draw completing deuce. So we actually have like 1.5 outs. And for that reason, only deuces with a clubs calls. And now I think the novice mistake is to say, oh, well, we block or we unblock the flush drop. It doesn't matter. That's a tiny effect. What actually matters is just how clean your outs are, right? So even a hand that feels like a static bluff catcher is to some degree drawing. And so when you're making decisions here, when you're looking at which hands to call with, I want you to think about one question. How can my hand make the nuts by the river? I want you to think of this about this all the time. Think about all the different runouts, not just the next card, but the turn and the river cards. Think about all the different ways your hand can become strong. right? How do you see turn reports? To access turn reports, what you need to do is first of all, load up a pre-solved solution. So not the AI solves, but one of these with all these different bet sizes. Here I'm just using the general NL500 GTO ranges. Then on here, it's going to ask me to select the board, and I'm just going to click turns instead. This will let me access the turn reports. And from here, I can see the strategy, the expected value, equity, and equity realization for one or both players. I can also filter for particular hole cards in the turn reports down here. Okay. All right. So back to the presentation. Draw equity. Let's talk a little bit about draw equity. So draws, as I said, they have the effect of rearranging the hand strength order. That's how I like to think about draws. So instead of thinking, oh, I have an open-ended straight draw, or I have a flush draw, or I have a backdoor this, what I think of it is what is the distribution of all the possible rivers that my hand can have. So, like, what are all the different 5 card hands that I make by the river? That's how I conceptualize draw equity. Another way to quantify it might be to think about the difference between your hand strength now and your hand strength at showdown. So your hand strength now would be like your static equity. Like if we just stop the hand now, how strong is my hand? Don't deal out any more cards. Whereas your draw equity might be like the difference between that and if you deal out the rest of the cards. So there's different ways to conceptualize what I mean by draw equity here, but hopefully you guys are understanding what I'm getting at. A very important concept in poker is the difference between static equity and draw equity. So static equity tends to depreciate as you narrow villains' range towards value. Static equity are usually going to turn into bluff catchers, and you typically want to pot control these hands. Draw equity tends to retain equity versus the top of your opponent's range. So even as you build a pot and narrow their range, draw equity tends to retain its value. And this is a key point that feels kind of obvious to say out loud, but it really goes very deep into building your strategy. Okay, so what do I mean? Maybe I can give you like a better visualization of what I mean by this. Let's take a look at this spreadsheet here. And I've used this one in previous coaching sessions. Essentially, what we're looking at is a button versus big blind single raise pot. The board is 10-8-3, two tones, so two hearts. Now, what I want you to think about here is what different hands will look like by the river. Not how strong is my hand now, but what does the distribution of my hand strength look like by the river? So in this graph, we have river equity. So this is the equity of our hand by the river and the frequency. So if we have a hand like Jack of Hearts, Seven of Hearts, this is a combo draw on 10-8-3. This hand is very, very polarized. So by the river, we're going to have this polarized distribution of very nutted equity and trash, right? And this polarization represents draws. Draws have polarized equity. Now let's look at something, let's say like two of clubs, two of spades. Okay. Now, two of clubs, two of spades tends to have static equity in the sense that it's typically just going to group around the same thing. So it's not super strong, it's not super weak. The vast majority of time, 2-2 is just going to be a medium strength hand or like a weaker hand in this case. And you can see there are some times where maybe, we hit like runner twos, right? Maybe we hit a very strong hand, maybe we make a boat somehow. But most of the time, our hand is just static, right? And so if we look at, let's say, ace of spades, 10 of spades, again, it's very static, right? Our equity is by the river, is typically just central around some value. And as we narrow our opponent's range, our ace 10 is going to get weaker and weaker and weaker. However, if we look at more drawish hands, let's say ace of hearts, 5 of hearts, obviously these hands are going to have more polarized equity. Or we could look at, let's say, a hand like 10 of spades, 8 of spades. So what does two pair? And 10 of spades, 8 of spades is more static equity, but its value, obviously, it's leaning towards the top. It does have some draws towards better hands. So this is how I like to conceptualize this stuff, guys. So let's say Jack of diamonds, 9 of diamonds. So an open ender, very polarized equity. Yeah, hopefully you guys get the picture of what I'm going for here. This is how I'm conceptualizing draw equity in my head. Okay. And so whenever you're like looking at a solution or you're thinking about which hands to call with, what you need to be thinking about isn't how strong is my hand now, it is how strong will my hand be by the river? What does my river equity distribution look like? If I complete my outs and let's say my hand gets stronger, do I also complete draws in my opponent's range that will devalue that? Right. So these are the types of questions you should be asking. Okay, build pots with draw equity, not static equity. Let me give a quick example of that. Okay, so back here, Why do we want to build pots with draw equity? Because again, it retains its value even as you narrow your opponent's range. So imagine that we want to build a pot here, or you attempt to build a pot here with something like ace nine, no clubs. It's not ideal, right? Because ace nine is typically going to have pretty static equity. And as we, let's say we check raise and we bet the turn and we bet the river, all we have is a pair of nines, likely a couple overcards. So we're going to have probably second, maybe third pair on the river, and we'll have narrowed our opponent's range to something much stronger than that. So you don't really want to attack with static equity. Static equity prefers to call, pot control, play it slow. Draw equity, on the other hand, prefers to attack usually, right? I'm going to make a kind of a bold claim here. So, draw equity has a pretty profound impact on poker. And if you kind of tuned out because the other stuff was a little too beginnerish for you, this is the time to tune back in. So, I'm going to make a very bold claim. Draw equity is responsible for merged betting strategies in poker. It is also responsible for donk betting. It is also responsible for range betting and for hypergeometric sizing. So draws have a pretty profound and wide reaching impact on the effect of poker. And this may seem a little grandiose to claim like all of these things are just due to draws, but I think I can prove most of it in this session. And we'll see if I bring you around to my point of view at the end. So we're going to start with a little bit of the scientific method. Now, good science involves isolating variables. And so the easiest way to study the effect of draw equity on poker is to study a game without draw equity and see what changes. So let me introduce you to the 0-1 game. Now, the 0-1 game is just a mathematical toy game. The rules are that we're heads up. Each player is dealt some random number from 0 to 1. So, you could get 0 or 0.5 or 0.83. The lowest number wins at showdown. There are 3 betting streets, and it plays like no limit hold'em otherwise. So we've got all the regular rules. Now, the characteristics of this game is that the hand strength order is static. So, a 0 will always be stronger than a 0.5 because remember, the lowest number wins. So it doesn't change. There's no shuffling of the hand strength order. Therefore, there's no draw equity. Every hand is static in that sense. There's also no card removal or blocker effects because it is a continuous range rather than, cards out of a deck. Okay, so this game is very, very well studied in poker academia. There have been like countless papers written about the 0-1 game. It's not very well studied on the poker side of things, though. There's very few actual poker coaching things out there that go over this. I cover it in my How to Solve Toy Games lecture. You can find that in the GTO Wizard coaching library. And another good resource is The Mathematics of Poker, chapters 16 through 20 by Chen and Ankerman. Now, the way that this game works is that betting strategies are always polarized. Thus, there's no merge betting, and calling ranges remain capped on the next street. Thus, there's never any donk betting. And so, this one here, this is a game without check raises. It is always perfectly polarized. So out of position, X just bets or bluffs. Y, they can bet or bluff, and then if they face a bet, they call this section, fold this section. So the strategy to this game is defined by thresholds. And I'm not going to go through the derivation of how to solve this. It's actually fairly complex as you add more streets. But regardless, even if you add more streets, even if you add in check raising, even if you add all the things that make no limit hold'em, no limit hold'em, the very act of removing draw equity also removes merged betting. And because your hand strengths don't change street to street, there is no donk betting. And by extension, if there's no merge betting, there is also no range betting. So if you have a 0.5 in this game, there is literally never any incentive to bet this hand, right? Because, I mean, what are you doing? You're just folding out hands that always lose and getting called by hands that, like, always beat you. So a middling strength hand has no incentive to bet, right? Now, let's talk a little bit about merged. For those unfamiliar with range morphology, we can roughly describe the shape of a range in 4 different ways. A polarized range has very strong hands at the top and weak hands. Linear is described as kind of like top down, strong to medium hands without the bottom of range. So a polarized range might be like betting in position on the river. You're either representing value bets or bluffs, and you're not betting medium strength hands. In the 0-1 game, you always bet polarized. A linear range might be like your opening range. You only open the best hands and fold the worst. A condensed range is like your calling range. You're calling medium strength hands, you're raising the good hands, and you're folding or bluffing the bottom, but you're not going to call with trash. And finally, we have merged bets. Merged bets are a function of draw equity. This happens when we're betting the top of the range, we're bluffing with the bottom, but we're also betting with middling hands, which is a bit weird. But this exists in poker, in real poker, simply because when there are draws, we can simultaneously fold out better and get called by worse. So a merge range, again, it's like a semi-polarized range. You're betting with strong hands, weak hands, and some middling hands. And the question is why we want to bet with these hands. Why bet the middle? Now, remember, merged bets do not exist in the 0-1 game, which implies they only exist when we have draws, when draws can exist. And so merges only exist in poker, really, when you fold out better and get called by worse. Thus, when there's a draw on board, what happens is you can fold out the showdowns in which that draw would have beat you and get called by showdowns where the draw might lose. Now, you can't actually control those showdowns, but the ability to fold out or get called by draws is why a middling strength made hand can bet in poker. Now, by the river, one might argue that we have merged bets out of position on the river, right? And the reason is, in this case, blocker effects, but also because the hand strength order has already been shuffled by the time the river arrives. So I would argue that without draw equity, even with blockers, you would have no merged bets. Okay, so in the 0-1 game, what about if you have a 0.4? Why would you bet polar with it since your opponent could have a 0.5 and you're getting thin value? So you could bluff. I mean, it depends on the distribution, right? Like if we're assuming symmetrical ranges where both players have a uniform distribution from 0 to 1, essentially in this game, in order to have a value bet, you need a hand that is ahead of the calling range. And in order to have a bluff, you need a hand that is behind the calling range. And so, like, what is ahead and behind is going to be dictated by a set of equations that describe how wide your opponent calls to your bet size. Typically, in a 3 street game, you just, it doesn't really make sense. Now, going on GTA Wizard examples, I think I've got maybe something that will make this idea a bit more clear because I think right now it's a little bit fuzzy. So, this is a polarized toy game where we are in the big blind and we have kings. The opponent has aces or garbage, complete garbage, right? And I want you to take a look and note that their aces almost always win, like we're drawing to only a king, and their garbage basically always loses, okay? Now, it should come as no surprise to you guys that kings never wants to bet here, despite the fact that we have 90% equity, despite the fact that we are way ahead of their range. Like, look at this distribution, right? If I showed you this without context, you might say, well, yeah, of course you should bet. Look how far ahead you are. But there's no point. If you bet, all you do is just fold out worse and get called by better, right? Now, I want you to take a look at one change. What happens if we change this from a 2 to a 3 of hearts? Okay, a couple things have changed here. We're still behind aces, but now all of these bluffs, or at least the ones with flush draws, have a chance to outdraw us. Okay, now if you're in the big blind, would you bet or check with your kings? We'll say it checks to us. I'm not actually going to click it to reveal the answer, but let's say it checks. Are you betting or checking? We got some bets in the chat. Right. So we go here, and now all of a sudden, kings is betting all the time. So the reason for this is that even though, again, we're folding out worse and getting called by better, we are also folding out better. We're folding out the rivers where our hand gets beat, right? And so just by adding in some draw equity, we now have had an incentive to bet a middling strength hand, whereas before would have no incentive to bet this hand. That's the magic of draw equity. It provides you incentive to bet a middling hand. Okay. Donk betting. So donk betting only exists in theory when the runout uncaps your range. And again, it's a consequence of draw equity. So you're going to donk bets in spots where, exploitatively anyway, you should donk bet in spots where you think villain will check back too often. And this is most usually going to be draw completers. Okay. So if we take a look at something like this, we'll do a little exercise for you guys. Okay. Cut off bets, big blind calls. Now, I want you guys to tell me what boards you think big blind should donk, or what runouts big blind should donk after check bet call. Okay, so Marco says a 9 or a 5. That's a good guess because presumably we're going to be calling with more second and third pair. So if we go here, you can see they only have 9.8% second pair compared to our 16.5. And third pair, even more so, the disparity is even greater. They have almost no fives in range, but we have 20% of our range is this. So second or third pair will promote a decent part of our weakest bluff catchers to trips. Clubs is more symmetric nuts. Yeah, that's also true. But let's take a look. Okay, so again, I'm going to use turn reports, and I'm not going to filter for any particular hand here. There we go. Okay, so as we guessed, a 5 is a good board to donk. A 9, not as much, but surprisingly, we do see that a 7 or an 8 are also decent boards to donk. And this is because these boards are draw completers, right? 7 or 8 complete some of the straight draws. And we also see that a decent number of the club draws give us some reason to donk, right? And this is because we have more draws in range. So it kind of depends how symmetric the the draws are. Like if both players have the same amount of flush draws in range and the same quality of flush draws, then you're not going to lead out. But yeah, in this case, like a 10, for example, completes a bunch of draws, but it also, yeah, not just straight draws, but also flush draws. So this would not happen without draw equity, right? You would not lead out unless the turn reshuffled the hand strength. And so I think maybe a novice concept is you're not sure like when you should donk out. So maybe you just always check the aggressor. But in actual game, you need to be thinking about, does this turn or river or flop, does this board card change the equity distribution in such a way that I am now ahead, right? Because in the static version of poker, you would never lead out because your range would just remain capped on every street. And so you should only donk when the board changes your range in such a way that makes it so that now you have some nut advantage. 8 seems strange when cutoff can have all the straights. Well, let's take a look at an 8. Okay, so 8. Now we have queen 10 in range. So do they. Queen 10, queen 10. And 10 8. Or sorry, we have more two pair, right? The big blind defense has jack 9, jack 8, even 5 8. Yeah, definitely more two pair. So if we put in, let's say, an 8 on board, let's say a non-completing 8, we can just go over to the ranges tab here and just compare what that looks like. Yeah, so we do have more straights. We have comparatively more sets. We have a few more two pair though. I think part of it is also that the 8 devalues their overpairs, right? So their overpairs, which were like a big part of their value advantage, kind of become less valuable, as well as their the top pair advantage isn't that strong. Yeah, I think it has more to do with devaluing the top of their value, which is something we mentioned earlier in this lecture, right? Like just because your hand doesn't feel like a draw doesn't mean that it's not affected by draws. Yeah, and yeah, you can also have donks on the river for sure. Okay, so I'm gonna move on to the mathematical framework. This is gonna be math, you guys. So toy games are useful, but they're not real. I'm gonna represent a nuts and draw in position versus a pure bluff catcher out of position toy game, and we're gonna compare it to the classic nuts and bluff toy game and see what changes. So here's the setup. In position shoves the turn. It's a pot-sized bet. We want to calculate how often in position should be bluffing, how often out of position should defend, and the optimal bet size. The math is a little complex, but essentially it goes something like this. We'll assume the draw has, let's say, 20% equity. Our goal is to make our opponent indifferent between folding and calling. So I want to calculate how often we should bluff. How often we should bluff is determined by how hard it is to make them indifferent. And so we have a set of equations here. We can calculate the expected value of calling using this equation, and we can solve this for B, the bluffing frequency, and find that the correct frequency of bluffing is 41.7%. Now, guys, I'm not showing you this because no one's going to calculate this in game. Obviously, that's insane. The real purpose of this is just to compare it to the other toy game, the classic nuts and bluff toy game, to see if the bluffing frequency increases or decreases. You can go and refer back to these equations later if you really want to derive it, or you can look it up in, let's say, mathematics of poker. Okay, so the bluffing frequency, and again, we've got nuts and bluff, or sorry. On the left, we've got nuts and bluff versus a bluff catcher. On the right, we have nuts and draw versus a bluff catcher. And so we want to compare how this changes. Now, in the nuts and bluff versus bluff catcher game, the bluff catcher always beats a bluff. And therefore, the percentage that we should bluff is just equal to the pot odds. It's a pot size bet, so 33%. However, when we replace our bluff with a draw, the draw decreases their incentive to call. And remember, we're trying to make them indifferent to calling. Therefore, we need to bluff more often to give them more reason to call. Right? So our bluffing frequency actually increases from 33 to 41%. So the main takeaway here is that when you're bluffing with draws, when you're semi-bluffing, you can bluff more often. You should bluff more often because your opponent's bluff catchers tend to have less equity against your range, tend to have less equity against your bluffs. Okay. Now we can calculate the same thing if there's a pot-sized bet behind. I've covered this before in my leverage video, but essentially pot odds compound over multiple streets. A lot of people don't know this one either, but if we have a classic nuts and bluff versus bluff catcher toy game, the bluffing frequency increases to about 55.6%. Whereas in this game, where we have a draw, it's about 69.4%. You can learn more about how to calculate these numbers in applications of No Limit Hold'em by Matthew Jonda. I've also done some sessions on this before, and I have this little caveman GTO calculator spreadsheet you can play with. I'll just go to that now. Okay. So imagine that we have a perfectly polarized range where our bluffs always lose at showdown and our value always wins at showdown. And we're just going to go pot, pot, pot. We can see the value to bluff ratio on each straight. On the river, we want 2/3 value, 1/3 bluff. But what many people don't understand is that pot odds actually compound over multiple straights. So you want more bluffs on the turn and even more bluffs on the flop. This ability to leverage your value over multiple straights is what we call leverage in poker. It's been written about many times. Andrew Brokos has written about it in Play Optimal Poker, as well as for GTO Wizard. I've talked about this concept in the leverage video on GTO Wizard's YouTube channel. But as you can see, you're going to bluff more and more. Now, we're making a few assumptions with this. We're saying that villain can only call or fold, but if we're perfectly polarized, that's a fine assumption. We're trying to calculate the balanced frequencies. There's no blocker effects. And here I've written equity is static. But what I actually mean by this is that the equity doesn't change. And so let's imagine that instead we have some draw on the turn, 20% equity. Say it's a flush draw with 20%. And we're only going to pay attention to the turn at this point because the rest of these numbers will be wrong. And the reason that the rest of these numbers are wrong is that our equity will change street to street. But on the turn, we can see that our bluff percentage, how often we should bluff, increases relative to a static bluff catcher, right? And so as our bluffs get stronger, we need to bluff more often. That's the key takeaway I want you guys to have. Another takeaway is that how often we bluff depends how much is behind. So if there's nothing behind on the river, again, we'll say that the turn shove is all in for 100% pot. We're just going to bet pot odds, right? 2/3 value, 1/3 bluff. However, if there's something behind on the river, now we can bluff more often because of leverage. If there's a lot left on the river, we can bluff even more often because of leverage. And if our bluffs get stronger, let's say 15% equity, we can bluff even more often, right? So the effect of semi-bluffing plus leverage on future straights increases our ability to bluff. Okay, let's move on to defending. Okay, so in position shoves pot on the turn with nuts for a draw. Now we're going to think about defense. So how often should out of position defend their bluff catchers? And I'm not looking for an exact number here, guys, but you should know that if this was nuts and bluff, then they should just defend according to MDF. For a pot-sized bet, MDF is 50%. However, here we don't have a bluff, we have a semi-bluff, we have a draw. Should they defend less often or more often? Or perhaps we don't have enough info. Take a moment to consider your answer. Now, in this particular toy game, the answer is actually defend more. So I don't know who that one person was that got the answer right, but yeah, the answer is technically that you should defend more than MDF, which feels insane because it feels like they're bluffing with a stronger range, right? Like, what is going on? It feels like this is the wrong answer. But remember what defending is trying to do here. The defender is trying to make the draw indifferent between bluffing and checking. How do we do that? So assume the draw is 20% equity again, and there's a pot size turn shove. Our goal is to make the in position draw indifferent between bluffing and checking. Now, we'll define some variables. So F for fold, Q for draw equity, 20%, and S is the bet as a percentage of the pot. So if we check behind, we can just take our 20% equity with the draw, right? So we're trying to make the draw indifferent between checking and taking 20% of the pot, because it's going to hit 20% of the time, or betting and winning 20% of the pot. So essentially, we have to make it indifferent to a profitable check. And to do so, you have to defend more often. Anyway, it kind of depends like how much the EV of checking behind is versus the expected value when called. Those two knobs will change this amount here. But truth be told, guys, this is actually not a very useful toy game because in practice, you're very rarely trying to make strong draws indifferent, right? Most of the time, if you're applying MDF to a spot, you're just trying to make like the bottom of your opponent's range indifferent from auto. Like you're trying to prevent them from auto bluffing with like complete garbage. It's very rare that you need to call wide enough to make draws indifferent, but there are some exceptions that I can show you. In particular, you should call wider than MDF when your opponent is all in before the river. Yeah. So let's go through this. Nuts and bluff versus bluff catcher. Typically, you're just going to call MDF in this typical toy game. But when it's nuts and draw versus bluff catcher, what happens is that they need to call wider. So draws have some incentive to semi bluffs. And so the defender needs to call wider to disincentivize bluffing, right? So the draw is kind of like they risk less as a function of their bet. This is a button versus big blind single raise pot. It's 200 big blinds deep, 10, 8, 3, 2 tone. We've bet pot on the flop, they've called. And now action is on us on the turn. This is the GTO strategy, is to bet. And this is what they defend with. Okay. Now, what I've done is I've node locked it this time so that we bluff with draws more often. So you can see ace 10 of diamonds is always betting, ace jack of hearts is always betting. I've node locked it in such a way that all of the flush draws are required to bet, but every other hand in its range can balance. And so this is a key point, is that sets, two pairs, over pairs, etc. These hands are free to adjust as they please. Okay? These hands can kind of rebalance as well as the garbage. So lots of the trash can bet as it pleases. So it's going to attempt to rebalance its range given the constraint that it has to bet its flush draws. What effect do you guys predict this will have on big blind? So we've forced button to bet their flush draws, but they are otherwise balanced. What effect will that have? Okay, so this is the original GTO solution. If we just look at how many hands are value betting in the best and good hands category, it's 55.5% overall. And here, if we look at the node locked version, we can see that they're bluffing more often. So they're value betting less often, bluffing more often, because now we're using more draws. Okay. So when we force them to use more draws, we also incentivize them to bluff more often. All right. I'll talk a little bit about the optimal bet size for this toy game. So it's a little too much calculus to derive this on a PowerPoint, but we will let n equal the turn stack to pot ratio, and we'll let q equal the probability of hitting the draw. And again, we're looking at the nuts and draw versus bluff catcher toy game, where the bluff catcher is essentially pacified. The optimal bet size on the turn is then given by this equation, which I've got a little Desmos demonstration here. Okay. So the way to read this chart is that on the right side is your draw's equity. So the x-axis represents how strong your draw is. The y-axis represents the bet size as a percentage of the pot, okay? And so down here, if your draw has no equity, in other words, it's a pure bluff, and the stack to pot ratio I'm going to set at 4, then the optimal bet size is geometric. You're going to bet the pot on the turn, and again, you're going to bet the pot on the river. That's going to put you all in geometrically, right? Now, as we increase the strength of our draw, what ends up happening, let's say we have a 20% draw, is that the turn bet, the optimal bet size is 143% pot. And this means that the draw, or the river bet size is only 66% pot. Again, we're still playing for stacks. We're still going all in because, we have the nuts and the semi bluff. We're still polarized, but we have more incentive to bet larger on the turn than on the river. Yeah. And again, this assumes that we miss the river. If we hit the river, then we just win kind of regardless of what bet size we have. We'll just bet and they'll fold everything. This assumes that we miss the river. So this is why I say that draw equity is essentially responsible for hypergeometric sizes, for sizes larger than the geometric bet size. It's driven by draw equity. I should also quickly mention that this is kind of oversimplified. In reality, as I'm sure you guys know, it's much more complicated. Our opponent doesn't have static bluff catcher. They are also drawing, and it's the quality of those draws that also matters. So what I'm drawing here are kind of like sweeping heuristics, trying to map out the global effects of draw equity. Okay, so one more toy game here. We've got nuts and bluff in position versus a draw out of position. In position shoves with a pot size bet on the turn. How often should we be bluffing and how often should out of position defend? Now, I'm not going to do the math for this because I've already kind of walked through several different math examples and it's a bit dry. And, you guys are poker players, not mathematicians. So I guess what I want you guys to think about is just conceptually, if we have nuts and bluff and our opponent is defending with a draw now, so this is a different toy game, they're defending with the draw, whereas we have just a pure bluff and pure nuts. Should we be bluffing more or less often? And should they be calling more or less often? Okay, let's take a look at the answer here. So the answer is that when you're bluffing, you should bluff less often. And how often should out of position defend? Well, you should defend the same amount, right? And you have to think about what each of these actions is trying to accomplish in game theory. So when we're bluffing in position, what we're trying to do in order to reach equilibrium is to make their bluff catcher indifferent. Now, a draw really wants to call, right? Because it is equity even against the top of our range. A draw really, really wants to call. And so we want to make it less incentivized to call. So we want to give them a worse price. And so we want to bluff less often in order to make their draw less inclined to call. On the other end, when out of position is defending, what they're trying to do is they're trying to make the bluff indifferent to bluffing, right? They're trying to make this bluff indifferent between betting or checking. In order to do that, they just need to defend MDF, even though they have a draw. And so the defense is the same. So you're still going to call, let's say, 50% of the time on the turn, but in position to be bluffing markedly less often in order to make the draw indifferent between calling and folding. The last thing to do is implied odds. So this is just a quick formula that you can think about. Implied odds is essentially the future amount of money we'll make on streets if we hit. And so let's say you have a nut flush draw. Villain bets 12 big blinds into a pot of 10 big blinds. You've got a 20% chance to hit. How much extra money do you need to win on average to justify calling the turn? And so the way you can solve this is just by setting up an expected value equation. We know the expected value of calling is how often you win times the amount you win, subtract how often you lose times the amount you lose. In order to do this, we'll just let M be the extra amount of money we need to win on the river, M for money, and we'll just add it to the reward side of the equation. So the 20% of the time we hit is we'll win their bet plus the pot plus some extra amount M. And when we lose, we'll just always fold. So if we miss, we just lose our call of 12. All we need to do is just set this equal to 0 and then solve for M. And if you plug this into Wolfram Alpha or just solve it by hand, you'll find that M is 26 big blinds. So we need to win 26 big blinds on the river in order for this to be good. So this is kind of like an old school implied odds calculation. How much is 26 big blinds? Well, the pot will be 10 plus 12 plus 12, so 34 big blinds. So they need to bet about 2/3 of the pot on the river in order for this draw to be good. Or they can bet less and then call a raise. If you're looking for a general formula, you can use this one here. So M is just equal to the lose percentage times the lose amount. That's the amount you're calling, by the way, is how much you lose if you miss, divided by the win percentage, which is the chance of hitting your draw. All of that subtract the win amount. So we'll end with some practical takeaways and wrap up this session. Generally, draws increase incentive to generate folds. So in practice, what ends up happening is that if you give your opponent a ton of draws, and we can maybe do a GTO wizard example. If you node lock them to have too many draws, you typically want to start attacking, attacking, attacking. You create a lot of incentive to generate folds, and you decrease incentives to call. We can also say that merge betting is generally a consequence of draw equity. And so the incentive to bet middling heads largely comes down to the fact that you can fold out better and get called by worse simultaneously, which happens as a function of draw equity. You want to build pots with draw equity, not with static equity. You generally want to pot control with hands that can't improve. And every time you're kind of thinking about what line to put hand in, you should really ask yourself, how does your hand make the nuts? And consider like, what are your paths to the nuts? If you get there, let's say you have a pair and you make two pair, does that two pair also complete your opponent's draws, right? Are your outs poisoned? This is a very important question, and it largely determines which hands want to continue and which hands do not, or which hands want to raise and which hands just want to check or, bet. So the solver, especially 100 big blinds deep, puts a lot of emphasis on the implied odds of your hand and like the value, like how good your outs are, how clean they are. So, okay, so let's take a look at some example here. Actually, we'll do the AI solve. That way we can node lock it. And we'll just take a look at what happens when we start blasting off with a ton of draws. Okay, we'll go check back call and we'll put like an 8 of diamonds on there again. I think 8 of diamonds is a nice card to node lock here. Okay, and I'm just kind of wigging this last example, but hopefully just to illustrate a point. I'm going to node lock their betting range here. And so if we first go into the filters here, we can see that open enders are often checking here, right? So what happens if we, first of all, I'm going to lock everything, lock all hands. And by the way, this is a new interface, guys. This interface will probably go live soon, but it's a little bit better. We've got better frequency locking and kind of a new, more intuitive way to to lock hands. Okay, so here what I'm going to do is I'm just going to have open enders and flush draws always bet. Okay, and we're going to have let's say the very, very bottom of their range. So like no draw trash hands. We're just going to have these hands always check, I think. These hands are okay. So all I've done is I've kind of replaced their bluffs with more draws. So I've taken out the bottom of their range and replaced it with drawish hands. I feel like this is probably closer to how people play in practice, right? People tend to bet their draws more and maybe not be aggressive enough with like pure trash. But we can see already that cutoff is raising quite aggressively, 17% check raising here, which is a lot. Let's compare it to what it was before. Open up strategy. Yeah, so you could see on the right hand side, this is the GTO range, and on the left hand side, this is the node locked range. And we can see that we're raising 17% here and only 10% here. Okay. And we're also defending wider. So you can see that here we're defending, we're only folding 33% versus here almost 40%. In general, you're going to find that anytime you node lock one player to put in more strong draws into their betting range, the other player, assuming they're not completely capped, is going to have more incentive to attack, right? And the stronger you make your opponent's range, like if I were to, let's say, remove even more trash, this effect will get even stronger. So if I go into combos here and let's say manual frequency, and I'll just make some of these like really trashy hands check. These hands can check. These hands can check. Like these hands just don't have very much equity. So we'll just check them. You guys can check. Yeah, we're still kind of working out the bugs with this interface. I have the joy of beta testing all the new stuff. Let me know if you guys like the look of this new interface in chat. Yeah, well, okay. So let's do that. So all I've done is I've made like the bottom of the range check more, and so this has made them more value heavy. But remember that they're betting, the vast majority of their draws are betting. In fact, I should maybe make these draws even bet a little bit more. So hand classes, manual frequency, bet, bet, bet. Cool. Yeah, looks good. Thank you. Okay, we'll put this in. And oh, actually, it might not have made it strong enough. Yeah, still raising pretty aggressively though. Anyway, you guys can do this on your own, but you can see that as I make the bluffs stronger and stronger, maybe I'll try one more time here. We're going to go hand classes. I'm going to scroll down to trash, and we'll just make the weakest hands always check. Yeah. At some point, the calls disappear, and you end up with a strategy where you're only raising or folding. So that's kind of the end game of this effect. Is if your opponents are like super draw heavy, then you just don't have any more incentive to call. All of your continues just become raises. Then again, that's largely a function of draw equity, because even if you're like raising into some nutted hands, sometimes it can be worth it just to fold out all if they're like strong draws and stuff, or make those draws go into a really bad spot. Anyway, that's pretty much it, guys. Appreciate your time. Thanks for sticking with me through this one. I know it's a little more math heavy than most, but hope you got something out of it anyway. If you have any further questions, let me know. Otherwise, happy grinding.